Hello friends, I welcome you all to this session on graph theory. So today we'll be learning about the theorem known as Dijkstra's theorem, and this theorem is basically used for finding the shortest path in any weighted graph. So let us learn that what is Dijkstra's theorem or algorithm and how it is implemented basically. So implementation part we will be understanding here. So let us consider a graph. So in this particular graph, there are 1, 2, 3, 4, 5, 6, 7. 7 vertices are there, and these vertices are connected via edges, and these edges are nothing but weighted edges. So some weight is assigned to every edge. And the task is to find the shortest path from A to G. Now, what we have to do, we have to make a table such that so 3, 4, 5, 6, 7. So 7 edges are there, and so 7 by 7 table will be making such that the top row is nothing but the edges, sorry, vertices. So here I am starting with the first vertex A because A is my starting one, and the ending column is nothing but the one where I have to reach. And in this way I have to write my header. And then the remaining 6 I will be filling up with numbers by certain mechanism, certain rule. And this rule is nothing but the Dijkstra's algorithm. So how to start? So first I have to do is I have to find out the distance of other vertices from vertex A. So here in the first column of this second row, I have to find out the distance of A from A, then distance of B from A, then distance of C from A, and so on. And if it so happened that any vertex is not directly connected to A, that means not adjacent to A, then for that I will be giving some number which is a huge number, which I don't know. That's why I'm giving a huge number, let's say infinity. So what is the distance of vertex A from A? It is 0. Okay, then what is the distance of vertex B from A? 2. Then vertex C from A, it is 1. Then vertex D from A, it is 4. Then what is the distance of vertex E from A? Now, they are not at all connected in a sense that they are not adjacent, and hence I cannot give anything. So I give infinity. Likewise for F and G. Now once this is done, we will fix this A. We will fix this A because this is the starting point. This is not going anywhere. So I will fix it. Then from the remaining elements, I have to find out the least one. So what is the least? It is 1. So I will mark it. Then come to next row. This row is over. Now whatsoever I have fixed, I will keep it as such. That's it. Then comes the vertex which I have marked. So I have marked what? Vertex C. So for that vertex, the number is 1. So I will bring that number and then fixed it. Then what I will be doing is I will be evaluating the distance of other vertices from the marked vertex, that is vertex C. So now what is the distance of vertex C from vertex B from C? So B is this, C is this, it is 2. So what I have to do is I have to add 1 to it so that I can reach. So what is the distance of vertex B from A now? Because this is already 1. So we have fixed it. So it is nothing but 2 plus 1, that is 3. But is it a shortest path from A to B? No. So what we will be doing is we will be keeping that number as such which is lower than what has been coming. So what is coming right now? It is 3. So 2 plus 1 is 3, but we cannot write it. So we will be bringing this 2 as such. Now what? Now comes what is the distance of vertex D from C. So D is this, C is this, it is 2. What is the distance of vertex C itself? It is 1. So 2 plus 1 is 3. Is the number 3 less than 4? Yes. So we will be writing 3 here. Okay. So if the new number is more, then keep the original number. So that is what we have done here. And here, if the new number is less, then write that less number. Then what is the distance of vertex E from C? So this is E, this is C, it is 5. And this is 1 already. So 5 plus 1 is 6. Is 6 lower than infinity? Yes. So we will be writing 6 here. Then comes F. So what is the distance of vertex F from C? It is 7. 7 plus 1 is 8. So we will be writing 8 here because 8 is smaller than infinity. Then what is the distance of vertex G from C? So they are not at all directly connected, means C is not adjacent to G. So we'll be bringing the number which is written there as such, that is infinity. Now, in this particular row, we have to find out that vertex which is having minimum weight. What is that? It is 2. Okay, then the work of this row is over. Then we'll be coming to the next one. So next one, in the next row, we'll be bringing all the fixed elements whatsoever we have fixed so far. So what we have fixed, this A and C are fixed, and then we'll be bringing that particular number which we have marked in the previous row. What is that? It is 2. So we'll be bringing it down, and then we'll be fixing it. Once it is fixed, now we'll be measuring the distance of all the other vertices from the vertex B. Okay, so what is the distance of vertex D from B? So D is here, B is here, they are not adjacent, so we'll be keeping the number as such. So 3 will come as such down. Then what is the distance of vertex E from B? So E is here, B is here, it is 3. So, and what is the distance of B itself? So 3 plus 2 is 5. Is 5 lower than 6? Yes, so we'll be bringing that 5 down. Then what is the distance of vertex F from B? So F is this, B is this, they are not at all adjacent. So we'll be keeping the number 8 as such down. Then comes G. So G and that is B. So they are not at all connected directly. That means they are not adjacent. So what we'll be doing is we'll be bringing this number as such. Simple. Now what I have to do? I have to find out the least element. So what is that? In these, 3 is the minimum. So we'll be marking it. Once this has been marked, the work of this row is over. Then we will be coming to the next row. And what we have to do? We have to keep all the elements which are fixed already as such. Okay, then we'll be bringing that 3 down and then fixing it. Once this has been fixed, then we'll be measuring the distances of vertices E, F and G from D. So this is E, this is D, they are not at all adjacent, and hence we'll be bringing this 5 as such. What about F? So F is this, D is this, the number is 4, and here it is 3. So 4 plus 3 is 7. 7 is lower than 8, so we'll be writing 7. What about G? What is the distance of vertex G from D? So G is this, D is this. Oh, they are not adjacent. So therefore, we will be bringing this number as such down. Now we have to search for the minimum in this particular number series. So what is the minimum number? It is 5. So mark it. So we have marked it. So the work of this row is also over. Now we'll be coming to the next row. So in the next row, we'll be bringing all the fixed elements as such. Okay, we bought them. Now we'll be bringing that element which has been marked. Which one has been marked? 5. Okay, then we'll be fixing it so that we can find the distance of other vertices from D. Why I am saying we are fixing it? Because this is the least distance to reach E from A. So this has been fixed. So we have fixed it. So now what is the distance of vertex F from E? This is F, this is E. They are not at all adjacent. So whatsoever is written here, it will come down as such. What is the distance of vertex G from E? G is this, E is this. So this is number 1. So weight is 1. What is the distance? 5. 5 plus 1 is 6. So 6 is lower than infinity. So it will come. So we'll be writing that 6 here. Okay. Now in this row, what we have to do? We have to mark the smallest entry, that is 6. We have marked it. Okay. Then the next one. In the next, what we'll be doing is we will be bringing all the marked elements. So what we have marked? So they will be coming as such. Sorry, fixed element we are bringing down. Then what we have marked? 6 we have marked. Then we'll be fixing it, and we will be finding the distance of vertex, remaining vertex, that is F from G. So this is F, this is G, the distance is 3. The distance of minimum distance of vertex G is already 6. Okay, so this is 3 plus 6. 9. So can I write 9? No, I cannot write 9 because 9 is more than 7. So therefore what will happen? 7 will come as such. So friends, in this way you have completed the table. Now the question is, what is the shortest distance to reach G from A? It is 6. Once you got this number, then you have to search for that particular path which is giving you this particular number 6. So here is the one. So now tell me, the shortest distance is 6. So what is that path? So if you look at, if I come from here, A to C, it is 1, 1 plus 5, 6, 6 plus 1, 7. No, I cannot because the number shortest distance is 6. What is? So 2 plus 3, 5 plus 1. Oh, this is the one. So I have to start from A, then reach B, then E, and then to G. So in this way, I can search for the path which is shortest. And this particular theorem is what we call as Dijkstra's theorem. So in this lecture, till this point only, in the next lecture, we'll be learning some more exciting things. Thank you very much. Take care.